Assalamualaikum. I am from Group 16 and I want to present about our mini project, Material Balance Mini Project, ECH3123. Let me introduce you to the member of the group, Afif, Muttaqi, Amira Najihah, Farah Batrisyia, and also Balqis.
So the first one, I will present about the hydrochloric acid. So the definition of hydrochloric acid. So the hydrochloric acid HCl is a strong corrosive acid and commonly found in laboratory and industrial applications. It's also strong reactivity that should be handled with care and safety precautions as it can cause severe burns and damage material. So for the background, the general overview is hydrochloric acid is a clear and colorless liquid that highly soluble in water. It also can form powerful acid solution and the chemical formula is HCl. And then you can see the HCl chemical structure. So aim for this study is to design a chemical process to produce liquid hydrochloric acid from organochloride residue. It also designed to reduce emissions and chemical waste that contribute a greener future and a more sustainable chemical manufacturing industry.
So for the methods used to produce HCl is the condition is for the feed, we have chlorine gas and also metal chloride. For the production per annum is 0.1 million ton, and for the method is recovery of HCl from organochlorine residue. Chlorination of organochlorine. This is the process of reacting chemical element with chlorine to produce mainly hydrochloric acid. So the chemical equation is CH3Cl plus 3Cl2 to produce CCl4 plus 3HCl. It also requires high temperature, which is 600 degrees Celsius, and catalyst, which is UV light and heat. And this method will ensure output is mainly hydrochloric acid.
Next, I will present about MSDS. What is MSDS? MSDS is Material Safety Data Sheet. So, there are few compound that we have at the block diagram. First, MSDS of chloromethane. The hazard is extremely flammable gas, may explode if heated, may cause damage to organs through prolonged or repeated exposure. The precaution is keep away from heat, hot surface, spark, open flames, and other ignition source. Do not breathe the gas. Use and store only outdoor or in a well-ventilated place. And the treatment is, if on skin, to frosted pipe with lukewarm water. Do not rub affected area. And if inhale, remove to fresh air and keep at rest in a position comfortable for breathing. So next, for chlorine, the hazard is may cause or intensify fire, contains gas under pressure, may explode if heated, cause severe skin burn and eye damage. For the precaution, wear eye protection, face protection, protective clothing, protective glove, and keep away from clothing and other combustible material. Next, treatment. If on skin, remove contaminated clothing, and if eye contact, immediately flash eye through with water for at least 50 minutes. So the third is tetrachloride. The hazard is cause damage to organ through prolonged or repeated exposure, and toxic if swallowed. May cause an allergic skin reaction. The precaution is used only outdoor or in a well-ventilated area. Do not eat, drink, or smoke when using this product. And the treatment is, if on skin, remove contaminated clothing immediately and wash skin with soap and water. If eye contact, immediately flush eye with plenty of water for at least 50 minutes. And last, hydrochloric acid. The hazard is may be corrosive to metal, cause severe skin burn and eye damage, and may cause respiratory irritation. And the precaution is do not breathe dust, foam, mist, vapors or spray. Wash thoroughly after handling and use only outdoor or in a well-ventilated area. And the treatment is, if on skin, remove contaminated clothing, wash skin thoroughly with soap and water, or use a recognized skin cleanser. And if eye contacted, irrigate copiously with clean water for at least 50 minutes.
My name is Farah Batrisyia with the matrix number of 228822, and I'm going to be explaining about the overall block diagram. First, we have heat exchanger. It is to heat up the processed to 600 degrees Celsius because in the reactor, it needs to be 600 degrees Celsius to break down CH3Cl into HCl and CCl4. Then next, we will go to cooling tower. It is to cool down the process to 25 degrees Celsius and 1 atm, and then to enter the condenser. And then, so in the condenser, it is used to separate liquid and gas. So the gases will enter absorption tower. So the main intent of absorption tower is to create a very pure HCl, which is what we need, and remove the impurities. And same into scrubber, we use wet scrubber, so we use water. So we remove all the impurities.
I will present about the chlorination, which is the reactor part. So the first block diagram. In this block diagram, we have reaction CH3Cl gas plus Cl2 gas to produce CCl4 gas plus 3HCl gas. The catalyst that involved in this block, which is UV and heat. The temperature is 600 Celsius. The pressure is 1 atm. So I use basis 100 mole. And then 0.25 mole over mole CH3Cl, 0.75 mole over mole Cl2 gas will enter in this block to produce N1 mole over HCH3Cl, N2 mole over HCl2, N3 mole over HCl4, and N4 mole over HCl. Intent of this block to react CH3Cl and Cl2 to produce CCl4 and HCl in the gases. So for my assumption, in this block, which is basis is equal to 100 mole, second fractional conversion of CH3Cl, 75%. So the DOF, the unknown is 4, the independent atomic species balance is 3, and the other info is 1. So the total balance of DOF is 0. The first calculation, I will use the 75% conversion of CH3Cl to know how a mole CH3Cl reacted, which is 25%. So I will got N1, 6.25 mole over HCH3Cl. And then I will use the calculation in method atomic balance, which is input is equal to output. So when I use H balance to calculate H balance, I will know N4 is 6.25 mole over HCl, and the C balance I will got N3 at 18.75 mole over HCl4, and the Cl balance I will got N2 at 18.75 mole over HCl2.
So for the condenser, the intent of this condenser is to separate liquid from gas, and for this case, we want to separate CCl4 from other element. So this is the block diagram, and we have 3 streams, the input and 2 of the outputs. So the DOF is, the unknown is 8, so the species is 4, and additive equation is also 4, and one of the additive equation is this assumption, which is 92% recovery of CCl4 at stream 3. This is also the reference. And for the separation hierarchy, we have the HCl is the lightest key because it has the lowest boiling point, and CCl4 is the heaviest key because it has the highest boiling point. So for the Anton's constant, this is all the Anton constant and all the references. And for calculation, the condenser calculation, we use pressure of 640 mmHg and also temperature of 28 degrees Celsius. This is the molecular weight for each compound and also mole fraction of the input of each compound, which is equal to 1. Then we calculate the mole fraction of input times total pressure, 640, and also we calculate the dew point. So for the mole fraction of gas stream, we calculate mole fraction times total pressure over dew point. Then we got for all and equals to 1 also. So for the mole fraction for the liquid stream, we use material balance, which is the input equals to the output. So we have 2 equations here. So we did the simultaneous equation to find the molar flow rate and also the mole fraction for stream Y. So then we got the the molar flow rate for stream Y and stream X, which is stream 2 and stream 3. So this is the value. This is the value.
Now I will explain about calculation on absorption tower. The intent of this block is it is a critical piece of equipment in chemical and industrial process used to separate, purify or remove specific components from a gas mixture by absorbing them into a liquid. So there are 4 feet that fit into absorption tower, which is 56.25 HCl gas, 18.75 Cl2 gas, 6.25 CH3 Cl gas, and N1 H2O liquid. And there are produced N2 H2O liquid, and 3 HCl liquid, and 4 HCl gas, and 5 Cl2 gas, and 6 CH3 Cl gas. So the DOF, degree of freedom, is the number of unknowns, 6, independent species balance, -4, molecular species balance 0, and other information is -2. The information is solubility of HCl in water equals to 7 to 0 gram per liter, and purity of HCl liquid is 37%. So first we need to find mass HCl, which equals to 2050.875 gram, and find mass HCl in liquid, and find mole HCl, which is N3 is equal to 20.8125 mole. Now we need to find N2 from volume of water, and we got 58.374 mole, and we need to find mole N4 by mass N4, and we got 35.4375 mole. From this equation, we got N5 Cl2 equals to Cl2 feet equals to 18.75 mole, and 6 CH3 Cl equals to CH3 Cl feet and equals to 6.25 mole. From the overall balance, we got input equals to output, and the equation is 56.25 plus 18.75 plus 6.25 plus N1 equals to N2 plus N3, N4 plus N5 and N6. And we got all the unknown, which is N1 equals to 58.3744 mole, N2 equals to 58.3744 mole, N3 equals to 0.38125 mole, N4 35.4375 mole, N5 18.75 mole, and last N6 equals to 6.25 mole.
Okay, so now I'm going to be explaining about scrubber, which is my unit. And so we can see this is the before from the unit before. We have all these numbers. And then the intent of a scrubber is a device that uses liquid, typically water or water-based solution, to capture the acidic gas by absorbing it from the gas stream. So my assumption is the efficiency is typically 95%, and I put some references too. And the solubility of water, HCl in water is 720 gram per liter. So we can use the degree of freedom. We have 6 unknown here, and we have 4 independent species, which is HCl, Cl2, CH3Cl, and H2O. And then the other informations are the assumptions before. So we can use the efficiency to get the N5, which is HCl in liquid, by multiplying the 95% with 35.44 mole HCl. And then from we can get mass of HCl by multiplying this mole with molar weight of HCl, which is 36.46. We can get this value, and then to get the volume of HCl, we will divide it with the solubility of HCl in water, and then we can get the volume of HCl. So from that, we can get the mole of water, which is the N6. And next, we can just use material balance, which is input equals to output, and N2 which is Cl2 equals to 18.75, and 3, which is CH3Cl, equals to 6.25. And then N4 equals to 35 minus N5, which is 35.44 minus N5, which is 35.44 minus 23.668, and then we will get 1.772 mole. And then N1 equals to N6, which is the amount of water coming in equals to the amount of water coming out. So it is 94.43362 mole. And this is the final units or value of all. Thank you.